Advanced course episode 1, you have built basic rag. It works mostly. Today we fix the mostly, hybrid search, cross-encoder re-ranking, and a trick called HyDE that boosts retrieval precision by 40% and without touching your LLM. Let's go. Hey, welcome to the advanced course. If you are here, you have already built with AI. You have called APIs, built something with RAG, probably shipped it to at least a few users, and you have noticed something. It works great on the demo questions and falls apart on the weird real-world ones. Let me show you exactly why and how to fix it permanently. Basic RAG follows this path. User asks a question. You embed that question into a vector. You search your vector database for semantically similar chunks. You send those chunks to the LM. The LM answers. Simple. But here is the crack in the foundation. Your user types Q4 refund policy. Your document says fourth quarter reimbursement procedures. Those two phrases carry the same meaning, Maxium. But as vectors, they sit in different regions of embedding space. Your semantic search ranks them as dissimilar. A completely unrelated chunk might score higher. The LLM gets the wrong context. It either hallucinates or says, I don't know, you did not build a bad system. You built the right system with the wrong retrieval strategy. And there are 3 techniques that production AI teams use to fix this. Every serious enterprise RAG deployment uses at least 2 of them. Technique 1, hybrid search. Hybrid search combines 2 retrieval methods. Dense retrieval is what you have been doing, embeddings, semantic meaning. It is excellent at understanding concepts, even when the exact words differ. Sparse retrieval is BM25, the algorithm behind Google's original text search. It scores documents based on exact term frequency, term rarity, and document length normalization. It is excellent at finding exact phrases, product names, acronyms, and numbers. Together, they cover each other's blind spots perfectly. The algorithm that combines their rankings is called reciprocal rank fusion. For each result from each retrieval method, you calculate a score using the formula 1 divided by the quantity 60 plus the rank. A document ranked first gets a score of 161, ranked second gets 162, and so on. You add the RRF scores across both retrieval methods. Documents that rank high in both float to the top. Documents that only rank high in one get a lower combined score. In practice, 60% weight on dense and 40% on sparse is the best starting point for most knowledge bases. Technical documentation with lots of specific terms, API names, error codes, product identifiers, benefits from pushing sparse weight higher toward 50 or 60%. Technique 2, cross-encoder re-ranking after hybrid search. You have perhaps 20 candidate chunks, but you only want to send the best 4 or 5 to the LLM. More context creates more noise, and more noise consistently degrades answer quality. A re-ranker is a cross-encoder model. Standard embeddings encode your query and each document separately, then compare them with cosine similarity. A cross-encoder reads your query and each candidate chunk together as a pair and scores that pair for relevance. It understands relationship, context, negation, things cosine similarity completely misses. The best accessible option right now is Cohere Rank 3, available through their API. For fully local re-ranking with no API dependency, BGE Re-Ranker V2 M3 from Hugging Face runs on CPU and produces comparable results. Both consistently remove 60 to 70% of irrelevant chunks before your LLM ever sees them. Technique 3, HyDE, hypothetical document embeddings. This one is counterintuitive and it is the one most tutorials skip entirely. Here is the insight. A question looks nothing like an answer. What causes inflation as a vector sits far from a paragraph that explains inflation causes. When you search with the question embedding, you are comparing apples to oranges. HyDE flips this. Before you search, you ask your LLM to generate a hypothetical answer to the question. It makes one up based on its training data. The hypothetical might have errors. That is completely fine. What matters is that it looks structurally like a real document answer. You embed that hypothetical answer and use it as your search vector. Now you are comparing an answer-shaped thing to answer-shaped chunks, and your retrieval precision jumps dramatically. Studies and production teams using HyDE consistently report 20 to 40% improvement in retrieval precision without any other changes to the pipeline. Here is the full advanced RAG pipeline in Python, every technique combined. First, set up the ensemble retriever. Create your ChromaDB vector store with OpenAI or Ollama embeddings for dense retrieval. Then create a BM25 retriever on the same list of document chunks for sparse retrieval. Combine them with LangChain's ensemble retriever, passing the weights list as 0.6 and 0.4. Then layer on re-ranking. Wrap your ensemble retriever with LangChain's contextual compression retriever. Pass in Cohere re-rank as the compressor, setting top 1n to 5. Your retrieval pipeline now returns the 5 most relevant chunks from your hybrid pool, not the 5 most superficially similar ones. Finally, add HyDE. Create a simple chain. Take the user question, run it through a fast LLM call with a prompt that says, write a paragraph answering this question, take the output as your hypothetical answer, and pass it to your ensemble plus re-ranker retrieval pipeline instead of the original question. The final answer chain reads the top chunks and the original question and produces your response. There is one more technique that belongs in every production RAG pipeline, and Anthropic published the research that proved it. It is called contextual retrieval. The problem when you split a long document into chunks, each chunk loses the context of where it sits. A chunk might say, the policy was updated in Q3. Updated from what? What policy? That context lived in the paragraphs before it allow, which are now in a different chunk. When you embed this chunk, you are embedding a piece of information that is partially meaningless without its surrounding context. The retrieval is accurate. You found the chunk, but the LLM gets an incomplete information. Contextual retrieval fixes this with a pre-processing step. Before you embed any chunk, you call the LLM with the full document and the specific chunk, and you ask it to write a short 2 to 3 sentence context explanation for the chunk. Something like, this passage is from the Q3 product policy update document and describes the revised refund timeline for subscription products. You prepend this context to the chunk before embedding. Now, your vector represents the chunk in its full context. Retrieval precision improves because the embedding captures meaning more completely. The LLM gets richer context in every retrieved chunk. Anthropic's published benchmarks show contextual retrieval reduces retrieval failures by 49% compared to naive chunking. Combined with BM25 hybrid search on top, that drops to 67% reduction in failures. These are not marginal improvements. They fundamentally change the reliability of your RAG system. The compute cost is real. You make one additional LLM call per chunk during indexing. Use a fast, cheap model like Claude, Haiku, or GPT 4o Mini for this. For 10,000 chunks, the cost is a few dollars and the indexing takes an extra 10 to 15 minutes. You pay this cost once. Every subsequent query benefits permanently. This is 30 to 50 lines of real Python. Once you have built it once, you never go back to basic vector search for anything serious. Your challenge for this episode is specific and measurable. Take any document you have, a PDF, markdown file, your own notes, your company's FAQ, build the hybrid plus re-ranking pipeline on it, create 20 test questions, 10 that use the exact terminology from the document, and 10 that use different words with the same meaning. Run both basic vector search and your advanced pipeline. Count how many times each wins. That gap is exactly what you just learned to close. That is advanced reg, hybrid search, re-ranking, HyDE. Build retrieval the way teams that get paid serious money to get it right actually build it. Episode 2, fine tuning. You will fine tune Llama 3 on your laptop in under an hour. See you there.